Yeah, so I'm Nathan Cummings. I work at UK Atomic Energy Authority in the UK. I'm a data engineer. I have a small data engineering group that I'm sort of growing, and we're looking to improve the quality and openness and general fairness of fusion data here in the UK, whilst also working with international partners to try and do the same thing. So this talk is basically a whistle-stop tour of all of the different sort of things that we've had to think about while we're trying to do this, and how we put together an open data service for some of our Tokamak data from the MAST machine, which operated between 1999 and 2013. But before I go into any of that, the first thing I want to do, because hopefully most of you are familiar with the FAIR principles and what they mean and what they stand for. But for those that are unfamiliar, I do just want to run through what the acronym stands for and what it kind of covers in terms of making data more usable. So stands for Findable, Accessible, Interoperable, Reusable. This was all defined in a paper published in 2016 by a large consortium of people, like multidisciplinary across many fields, to define principles for research data stewardship. So the F, Findable, I won't go into all of these in a huge amount of detail, and I'm also going to try and move the gather.town window so I can actually see what's on the slide. Cool. So under Findable, the principles involve making sure that metadata are globally unique and there are persistent identifiers, and that there's lots of rich metadata, and that they clearly and explicitly include identifiers for the data that they describe. And that they are indexed and made available by some searchable resource. So that all goes towards the findability of your data by having all of that information in your metadata that you publish. The A stands for accessible. So you need to make sure that both the metadata and data are retrievable by those unique identifiers by some standard communication protocol. And that protocol needs to be open, free, and universally implementable. Sometimes you need to have authentication, authorization for data. Fair and open are orthogonal. They do not mean the same thing. Data can be fair and not open, and data can be open and not fair. So that's important to point out. And that the final point is metadata need to be accessible, even if the data no longer are, or perhaps aren't yet available. For example, if they're under some kind of research embargo, which is pretty common. Now, for interoperability, this is about making sure the data that are shared can be used in lots of different applications. So both the data and the metadata need to be broadly accessible in some applicable language. The vocabularies used to describe the data themselves need to follow FAIR principles. So if you use a vocabulary to describe your data, then people need to look at that vocabulary to figure out what those words mean, right? So, for example, the talk that Olivier just gave on the open sourcing of the IMAS data dictionary is really important, because people are going to use those terms. Then people need to be able to look up what those terms mean, or else it really loses some utility and interoperability. They need to include qualified references to other data sources that are related. So if you've got metadata referencing data, those references need to be fully qualified. For reusability, this covers the essentially metadata needs to be richly populated with lots of relevant attributes so that people know what the data are that they're using. And data and metadata need to be released under a clear and accessible license so that people can understand how they can use the data going forward. Detailed provenance is important for reusability. We need to know where data came from and how they were generated and processed, or else we're not talking about reproducibility, which is obviously fundamental in the scientific process. And that where possible, the data and metadata conform to some domain relevant standard, which is again why it's so important that we think about the IMAS framework that Olivier was talking about, because in terms of a common standard for representing fusion data, it's the only game in town, and we should all be paying attention, in my view. So To talk about MAST, this is the Mega Ampere Spherical Tokamak. As I said, it ran from 1999 to 2013. It's a spherical tokamak that was commissioned by both Euratom and UK Atomic Energy Authority, and it's here at Culham. It's just in that building just behind me there. Over its history, it produced roughly 30,000 shots, and it's now succeeded by MAST-U, which began operations in 2020. Apologies that some of the photos cover some of the text there. There was probably some animations in the slide once upon a time that have gone lost along the way. Right, now talking about how to make data available publicly, the first thing I did when I wanted to make the MAST data open was to look at what was going on in other fields. So in the earth science community, there's a community/software stack known as Pangeo, and one of the key people leading this effort is a chap called Brian Abernathy, and he had a blog post 2018 where he advocated for the idea that if you want to create a big data portal, use a cloud object storage for to share your data, and use a self-describing and cloud optimized format. And if you do those things, that's it, you're done, right? The blog post is really good. I do recommend it. It's a little bit tongue-in-cheek. There's some stuff missing there, but that does get you like a good 80% of the way, right? But one of the most important things that it doesn't account for is one of the key principles of FAIR. So the second principle in accessible is that metadata are accessible even when data are no longer available, or as I said, if they're still under embargo, not yet available. So that's an extra dimension that you don't get by just putting netcdf files into like AWS and making it public. So you've got the situation where you've got to have your cloud data and then some other representation that's searchable for the metadata. So these two things have to exist separately but kept in sync with each other. So a metadata database with some kind of API for querying it, and then that gives you like URLs or some unique identifier for a data that are in cloud object storage. This is basically the method that we have approached for sharing MAST data. So for the metadata database and the query API, very simple, like Postgres database, fast API, API on top, and also GraphQL API is also available for more complex queries. This is what we've implemented for the FAIR MAST projects. But for data in cloud object storage, that's not quite so obvious how you do that. What kind of formats do you use? Where do you put it? Things like this. So we'll have a look across the existing data engineering landscape to see what kind of products are available. We didn't have to roll things from scratch too much, because then you have to maintain these things forever. And if there are off-the-shelf tools, especially open source things, are free and open source, that's all the better. So one of the main problems that I found with a lot of the existing technologies in data engineering world, aside from the fact that a lot of them are closed source or they have an open source offering, but then a lot of the useful features are locked behind the commercial part of the software stack. Also, a lot of these tools are geared towards supporting tabular data only, right? Which is fine for a lot of the data engineering world, but for Fusion, we have multi-dimensional data. So this is an image that I've taken from the X-ray documentation, that it's geared towards like weather and climate data. But if you squint a bit, you can quite clearly see how perhaps without too much change, this is sort of relevant for Fusion data as well. So the question is, what format do you use? You need something self-describing, right? So multi-dimensional data formats that are self-describing, there are really like three options that are sort of major in my view. So HDF5, NetCDF, and there's another format called ZAR, which was developed by the Pangeo folks. So cloud optimized is the other requirement. And of these three, that is ZAR. That's what it was designed to be, a cloud optimized way to store multi-dimensional self-describing data. So this is what we used for the open MAST data as well. And then when you're making these technology choices, and if you choose ZAR as a format, there's this whole suite of nice, useful Python tools, which a lot of us are hopefully somewhat familiar with, that all are designed to play nicely together. So this is what is known as the Pandata stack, and there are many different tools in this chain that we use for mass data, and then other people can use for analyzing and working with it. So as I said, yeah, we have a metadata API as a REST API, fully documented. We also provide a bunch of Parquet files that are easy to read into a Pandas data frame. If you don't want to be using the REST API for whatever reason, it's just another option to stay in Python land much more easily. So what this essentially means is, because it's all completely open, I like this nice example of being able to load MAST data just with 2 lines of code if you want. This is an example that shows using a group of data we call the summary, but you could easily put equilibrium or constant scattering or whatever else in here once you've done the search of what's available using our REST API or the Parquet files. And this is a bit more long-winded example, but a bit more explicit, that shows how to access the data directly. And then also, if you want to bulk download a bunch of the data, it's S3, right? This is a universally implementable open protocol. There are many CLI tools. We quite like S5 CMD because it's nice and fast and parallel for transferring data from S3 endpoints. So there's some examples there. Similarly, on our documentation pages that we built using JupyterBook, these examples are listed there as well. And I will make sure the slides are available to be shared if the organizers are posting them somewhere. So that obviously anybody that doesn't have a chance to get the QR code or the URL now can do so after the talk. So the next stage that I have for this is to make sure that there's some way to version these data, because I'm essentially taking data from the MAST archive here on site and re-representing and re-curating them for the public. What we need to do is make sure that those are properly versioned, because we're doing things like changing the names of stuff to conform with, for example, the IMAST data dictionary. And as these changes happen, people that are building pipelines from this data, things will start to break. So as a sort of a matter of urgency, these are some of the tools that I'm looking at to try and implement a versioning scheme. And then there's also lots of requests for facilitating data sharing, so that people can move the data closer to their compute, which is perfectly reasonable. So tools like Globus and CVMFS and different ways to move data we're also looking at. And the final thing that I want to discuss is federation. So we've got lots of efforts ongoing around the world, most of which I'm involved with to some degree or another, that all aim to make Fusion data more open and accessible. So there's this project that I've just been talking about. There is a project led by Christina Rea at MIT that is also working towards this, as well as a project led by General Atomics and Brian Sammerly. The Large Helical device at NIFS in Japan, they have made all of their data open using Amazon's Open Data like Sustainability Data Initiative for free, which is a very interesting way to host data for free if it goes towards sustainability and you want to make it open. So that's Nakanishi-san that's working on that. The IAA have an ongoing project to develop a Fusion data lake to facilitate sharing Fusion data between different countries. And also West recently announced that they're going to make their data open subject to a two-year embargo, and the technical implementation of that is just beginning, led by Frederick Imbo, which is fantastic news. So what my point is like, wouldn't it be great if all of these open sources of data could federate, so that you can go to any one of these different sources and see the data from all of these different efforts without having to like jump between different platforms? This is possible. This is perfectly possible. It needs some standardization on searchable terms, some metadata terms that we need to align on, and we need to make sure that there's a universally implementable protocol for accessing the data as stated in the FAIR principles. But this is something that we could absolutely achieve, and there are other fields like in astronomy and earth science that benefit from this kind of approach. So just in the interest of time, I won't go through each of the points in summary. So feel free to look at the slides afterwards. But yeah, thank you all for your attention. And if you've got any questions for me, I'll be happy to answer them.
Thank you, Nathan, for the excellent talk. I see no current questions in the Q&A, but if anybody has one, feel free to chime in. Otherwise, I will start asking questions myself. Oh, okay, we got a few popping into the chat. How does this project from Jerome Alhage, how does this project do for very long-term durability? When the money runs out, people have retired and servers are offline, can a user read and figure out the data model?
Yeah, so this is why in the FAIR principles, they have this principle A2 about making sure metadata are available even if the data no longer are. A small database hosting metadata running on a server is not expensive. Like it's like STFC colleagues of ours that we collaborated with to develop this work that are only about a 20-minute drive in that direction. They provide a publicly facing server for us to host this stuff for free. We asked them, can we have a VM? How much would it cost? And I gave them the specifications and they laughed at me and said, just have it. It's fine. It's in the noise. We don't even notice. So as long as somebody's prepared to just keep an eye on, make sure these things are still up to date, then at least the metadata is still available. There are, depending on who your funders are or who you're publishing with, there are certain requirements on how long data need to be kept accessible. And obviously you need to adhere to those for the actual data. But really, there's no good reason why metadata references shouldn't be able to stick around for basically perpetuity. Yeah, hopefully that answers that question.
From Olivier Honan, is federation something which is possible only for open data?
No, not at all. If there is authentication required for data, there are technologies available for federating authentication and authorization platforms. For example, whenever you go to websites and you need an account, you can click the, use my Facebook account, Google account, GitHub account. Using technologies like Keycloak, we can federate authentication sources. And then, so if data are not open but fair, it would take, some software engineering effort to have platforms that can support these things and to federate authentication layers, but that's also completely possible.